When you go for a long jog or hike, it's always considered a good practice to carry water with you. To bring your water, you will need a water bottle to store the water. Your water bottle works as a storage container to carry the water. If you like, you can put different things in this bottle. You could carry juice or you could carry milk. Your water bottle acts as a container to carry various liquids. As you will see, variables are like containers in that you can choose what you want to store in them. Your calculator's memory acts like two different water bottles to store two different numbers. Let's call it water bottle X and water bottle Y. Just like in your water bottle, you can carry different liquids. In a calculator's memory, you can store different numbers. Once your variables have values, then they can be used. Here, we decided to use 5 for the first variable value and 3 for the second variable value. And the neat thing is, once you get your answer, if you want to run another calculation, you can choose a different set of numbers for your first number and your second number and run it through the process. And you don't have to reprogram the calculator or change your code. We're going to create a brand new console application to start working with variables. Let's go File, New, Project. And we're going to call this one Working with Variables. Notice I have spaces in the name. That is allowed. Now, let's make sure we're in the correct folder. This will be Chapter 2, Lab 2.1. Visual Studio created the main method for us. Let's do a simple program. Let's create an integer called my age, and we'll set that equal to 35. Let's go ahead and show the age and pause the program. Let's do a console.writeLine, and let's put in my age in the parentheses of the write line. And then we'll do a console.read key at the end, so we pause the program. Let's run this. There, it says 35. Excellent. Can an integer store a negative number? Let's say my age is negative 35. A little time travel. I will be born 35 years from now. Yep, negative 35 can be held by an integer. We're going to change this data type to what's known as an unsigned integer. Notice we get the red underline, and the code won't run. That's because an unsigned integer is an integer that will only take numbers 0 or above. In other words, only positive numbers. No numbers with a sign before them. If we change it back to integer as the data type, it will work. But this might be a little bit excessive because integers can go up to just over 2.1 billion. Now, I've known some people who lived pretty long, but nobody approached 2.1 billion years. So since age can't get very big, maybe we can use a smaller integer. In other words, there is a smaller type of integer that takes up less memory, and it is called short. Can short hold negative 35? It sure can. Can short hold positive 35? Yep. Can it hold the oldest person listed in the Guinness Book of World Records, which is somewhere around 125? No problem. Let's just make sure. Can it hold 1,000? Yep, it can hold 1,000. Can it hold 100,000? Let's test this. Nope, we get an error. That's too big. The short is like an integer that can go up to about 32,750 and about negative 32,750. If we wanted to be able to hold 100,000, then we need a larger integer than short, the integer itself, because that goes up to 2.1 billion. Let's run this, and notice it works just fine, and we get 100,000. Here are all the integer numeric data types available to you. As we saw, the short easily handled 1,000, couldn't handle 100,000. Its range is negative 32,768 to positive 32,767. We also played around with the integer. And we could see that it could take negative numbers and positive numbers from negative 2.1 billion to about positive 2.1 billion. And we also tested the unsigned integer, and we tried to feed it a number below 0, which it can't accept. We tried to feed it negative 35, and it didn't work. The other data types and how they work are listed in this grid. 7 is an integer, but 7.1 is not. So if you're going to have some decimal points, you can't use any of the integer data types. You're going to have to use one of these floating numeric points. Now, how big can they go? Well, it kind of depends upon your precision. What is meant by that? Well, let's look at this. 5.0999999 is not any larger than 5.1, but yet it's more precise. So based on the number of decimal points, pick the right data type that will fit with what you're trying to store. Now here's where we left off, using the integer numeric data type. We're going to want to work with some other simple data types. Let's delete this first line of code, and let's delete the variable from the right line. Now, we're going to use a different variable. We're going to use a string, so we'll type string, and we will say author, A-U-T-H-O-R, is equal to me, M-E. And then we will pass the author variable into the right line. Now running this code, it should say me. So the string data type is great for holding keystrokes, letters, numbers, everything that you can throw at it. Now there's another data type that's similar. It's called char. Let's put C-H-A-R. It stands for character. We already see a red underline. What's wrong? Well, two things. A char only holds a single letter. A single letter like the letter M. Now we think we're in good shape. But we still get an error message because chars do not take double quotes. They take single quotes. Now we should be able to run this code. There. It just says the letter M. Let's look at another common type. This one is called bool. Bool? What is that? Well, that's short for Boolean. And a lot of people say, well, what is that? A bool is a yes, no, true, false. It can only have two possible values. M is not one of its values. So what we're going to do here is we're going to say bool is equal to true. And we will run that. And it says true. The only other possible value for a bool is false. So let's try false. Run it, and it says false. Now we're going to work with declaring, setting, and naming variables all at once. Let's change this to int and change the variable name to my int variable. Let's give it a value of 1,000. And let's put my int variable inside the right line. Does this work? Great. It says 1,000 just as expected. Now, what happens if we don't pick a number? We declared it, but we never set it in memory. We get an error. We cannot use a variable if we haven't set a value. Do you have to set the value now? I mean, what if the value is coming from a website where the user enters their age or the user enters their lucky number? You don't know what their number is at the time you're writing this code. That'll come in later. But yet you want to reserve the memory ahead of time. So, another line might go out to the web and capture this value. My int variable is equal to 1,000. Now this will run. We're declaring in one statement, and we're setting it later in another statement. And it works just fine. Let's change the name of this variable. Instead of my int variable, let's call it at my int variable. Let's see if it's happy there. It accepted that name just fine. Why don't we start the variable name with an underscore? Underscore my int variable. Is this valid? They all match up. Let's see if this works. It works just fine. You can start variable names with underscores. How about one my int variable? Can you start a variable with the number? No, you can't. Wait a minute. Are numbers not allowed in variable names? How about my int variable 1? We'll end it with a number. Can I end a variable name with a number? It sure does work. You can use a number anywhere in the variable name except you can't use it at the very first letter. We know we can start a variable with an @ sign. Can we end the variable with an @ sign or have an @ sign in some place other than the first letter? Well, let me put an @ here, here, and here at the end. And it's not looking happy. No, we get an error message. Looks like we can't do that. Here's a summary from the book that explains what names can and can't be used for variables in C#. Now go back to your main, delete out your code, and let's start with 3 different integer variables. One called first number, one called second number, and one called total. Kind of like we're a calculator, but don't set the total yet. That will be calculated later. What we want to do here is show the results to the screen. Let's say console.writeLine. And for the write line, we will put in the total. Now remember what happens when we try to write line a variable that hasn't been set yet. Well, let's go ahead and console read key at the end and get everything all set up. And of course, the code doesn't work. That's because we need to make sure the total variable is set. I should set it to 50, shouldn't I? That would work and be accurate. There, it says 50. The problem with that is if we change one of these first numbers, then this 50 is no longer the right total. So instead of setting it to 50, why don't we set it to be equal to the first number plus the second number? And now run the code. There, it says 50, and it came dynamically. Just to prove it, let me change the first number to 21. 21 plus 30 is now 51. Okay, we want our 20 and 30 numbers back. We're going to display this to the screen in a little more friendly way. We're going to put a message right before the total to say the total is, and then plus the variable, and run it. Now it says the total is 50. So you can concatenate strings with variables inside of the write line. Well, let's put it all together. What we want it to do is say this. Sum of 20 and 30 is 50. How do we make sure that these numbers are not going to be hard-coded, but they're going to grab whatever number comes from their corresponding variables? So variable 1, variable 2, and variable 3 will be in place of this sentence. Now, numbering in C# is ordinal, where it's going to say this is variable 0, and this is variable 1, and this is variable 2. So let's put that in place. Put a 0 here, let's put a 1 here, and a 2 here, all in curly braces. Now, all we need to do is put a comma here, and for the 0th position, we put in the first variable. For the number 1 position, we put in this variable, and for the number 2 position, we'll put in the third variable, and run it. And look how it put our sentence together dynamically. The sum of 20 and 30 is 50. Is it really working dynamically? Well, let's test by putting the first variable to the value of 21. And it looks like everything adapts. The sum of 21 and 30 is 51. Time for Lab 2.1, Skill Check 1. Take a moment to pause this video and challenge yourself to do this skill check. Skill Check 2. Take a moment to pause this video and do this skill check. And that was Lab 2.1 on data types. Our next item, Lab 2.2, operators and expressions.